Hi, I'm Amr Ahmed, a CFD engineer. I have a master's degree in studying the aerodynamic performance of Savoni's vertical axis wind turbine. Here we have a two-dimensional CFD model of Darrieus vertical axis wind turbine. The model is parametric, validated against experimental results, and with domain size, mesh, and time step independent studies. These are the files you will download, and by extracting these 3 7-zip files, we have now 5 folders and a guide PDF. The first folder, Darrieus 2D-CFD models, contains different 24 models. If we get inside, here we have 3 folders for 3 different types of trailing edges: round, blunt, and sharp trailing edge. And inside each folder we have different 8 workbenches. You can work on any of them depending on your case. Is it a rotor only, or rotor with a stator, with shaft or without shaft, and whether you need the step of ICEM smoothing or not. ICEM smoothing is an optional intermediate step between ANSYS meshing and Fluent. It is a good option for enhancing the mesh quality, but it's not practical if you need to make an optimization study through ANSYS Workbench. This folder, Independent Studies, contains the 16 runs performed for the domain size, mesh, and time step independent studies. And this folder, Validation, contains the 8 runs of the validation curves runs at different 8 values of tip speed ratio. Both folders for the same case taken from this experimental paper I used to validate the model. The results of the independent studies and the validation are in this Excel sheet, and this is a validation curve. And this one, parameters of Darrieus 2D model, contains the parameters used in the workbench, as will be shown later. These 2 Excel sheets are to monitor the solution, and there is a video explaining how to use any of them. This folder contains videos showing how to change the parameters and update the workbench, how to monitor the solution by the Excel sheet, CB average calculator, and more. This is the project schematic. This model here is with ICEM, and for models without ICEM, this cell will not be here, and the links will go directly from ANSYS meshing to Fluent. The steady model moving reference frame is used here as an initial solution for the main model here, which is a transient sliding mesh model. And here are the parameters like rotor diameter, chord length, number of blades, pitch angle, shaft diameter, and so on. Also, domain dimensions, Fluent parameters, and mesh parameters are here. Almost any parameter you need, you will find it here. Maybe except the airfoil section, because changing the airfoil coordinate file is unfortunately not available as a parameter in ANSYS. This is a guide PDF file which is so important to read before working by the model. It explains the parameters and contains important notes. Finally, I did my best to explain the details of the CFD model, but if you are a beginner in CFD and needs more basic level explanation, stay tuned for my course about simulating the aerodynamic performance of different types of wind turbines. It will be available soon. Thanks for watching.